Hi everyone! Today we're going to be doing a fraction review. We'll call it a fraction jubilee because we're going to be covering a lot of different objectives. We're going to go over how to determine if two fractions are equivalent, how to convert between mixed numbers and improper fractions. We're going to be adding and subtracting fractions, both with the same denominators and with different denominators. And lastly, we're going to multiply and then divide fractions. So we have a lot to cover, so let's get started. I'm going to let you know that I have two problems for each type of problem. So the first one, I'm going to explain how to do it, and then on the second one, I want you to pause the recording and then try the problem out on your own so you can see if you're doing it right. Okay, so make sure that you have a piece of paper out so you can try out some of these problems. For this first one, we're asked to determine whether the fractions are equivalent, which means we want to know if they represent the same number. And so we can either reduce the two fractions to lowest terms and see if we get the same fraction, or we can get a common denominator. And I'm going to show how to get a common denominator. So we're looking for the least common multiple of 20 and 40, which will give us our least common denominator of the two fractions. So if we skip count by 20s, 20, 40, we get to 40, and that's actually the other denominator. So the least common denominator is 40. So I'm going to go ahead and change the 5 over 20 to have a denominator of 40, which means I need to multiply that 20 by 2 to turn it into 40. And if you multiply one side of the fraction by something, you need to multiply the other side of the fraction by the same number. So we're going to multiply top and bottom by 2, and we're going to get 10 over 40. And then we compare that to the other fraction, 15 over 40, which is not the same as 10 over 40. So the answer to this question, are the two fractions equivalent, is no, they're not equivalent. If we had gotten the same answer for both, once we either got a common denominator or reduced the fractions to lowest terms, then they could have been equivalent, but these are not equivalent. So here's the second problem. I'd like you to pause the recording right now. Try this problem out on your own, see if the two fractions are equivalent, then unpause when you're ready to check your answer. All right, so checking our work here, we get that 7 over 49 being changed to have a denominator of 147. We would multiply the numerator and denominator by 3, and we get 21 over 147, which is the same as the other fraction. So yes, these two fractions are equivalent. Okay, so now we're going to move on to our next objective. We're going to write this improper fraction as a mixed number. So to do that, we take our numerator and we divide it by the denominator. So 81 divided by 11. We see how many times 11 goes into 81, which is 7. 7 times 11 is 77. If we subtract those two numbers, we get 4. And that's the remainder. And we're going to write that remainder over the original denominator. So we have 7 and 4 11ths. Remember that a denominator is simply splitting up a whole into a certain number of parts. So we're just splitting everything up into 11ths, which we had 7 whole 11 parts inside our 81, and then we had 4 left over. So that's why we end up with 7 and 4 11ths as our mixed number. Okay, so here's the second problem. Go ahead and pause the recording and try this one out. So go ahead and check your answer. For this one, 6 goes into 59 9 times, and there's 5 left over, so we have 9 and 5 6. Okay, now we're going to go the other way. We need to change this mixed number into an improper fraction. So in order to do that, we're going to multiply the whole number part by the denominator. So 3 times 7 would give us 21. And then we need to add on the 5. So we had 21. So we end up with 26 over 7. Now written out so you can kind of see why that's true. 3, if you change it to have a denominator of 7, we really are multiplying by 7 over 7, and we get 21. over 7. And if you think about it, 21 divided by 7 is really just 3. So that's the same as 3. So if we have 21 sevenths and we have 5 sevenths, that's really 26 sevenths. So that's where all these little calculations are coming from. We multiply the whole number by the denominator and then we add on the numerator and we end up with 26 over 7. Okay, so here's one for you to try on your own. Please pause the video now and then check your answer when you're ready. Okay, I've shown my work in both ways, so you can check the way that you like. You can either change the 4 to a 4 over 1 and get it with a denominator of 5, so 20 over 5. Or you can multiply the 4 by 5 and get 20. And then we're going to add our 2 to that to get the 22 fifths. Okay, we're going to move on to our third objective, which is adding and subtracting fractions. We're starting with same denominators. So I'm going to suggest that for most of these problems, unless you have another way that's working for you and you're getting all the same right answers, I would request that you start by getting everything turned into an improper fraction. So we're going to do 3 times 5 to get 15, plus 1 to get 16, and then we have it over 5. Now we're going to do our second mixed number. So 4 times 5 is 20, plus 3 is 23. So we have 23 over 5. And again, notice we have the same denominator, which we need in order to add the fractions together. So this one's pretty easy. You can just add the 16 and the 23. And if you do that off to the side, you're going to get 39. So we have 39. And when we add our two fractions together, we keep our denominator the same. So we have 16 fifths plus 23 fifths equals 39 fifths. And then if you want to change that back into a mixed number, you would do 39 divided by 5, which is 7. And then we have 4 left over. So that would equal 7 and 4 fifths. Okay, so that's our mixed number answer. All right, here is one for you to try. So it would help to change this second fraction, 2 2/9, to an improper fraction, and then go from there. So go ahead and pause the recording and try this one out. All right, we've got our work up here, and you should end up with 2 4/9 for this one. And again, if you can see a different way to do the problem and it's working for you, then you can use that way, as long as what you're doing makes sense as regards to the rules of fractions and what a fraction really represents. Okay, so now we're going to finish this up with adding and subtracting and doing different denominators. So now we have a 5 in our denominator and a 10. And we need to get a common denominator in order to subtract these fractions. So it turns out that the least common denominator here would be 10, because 5 goes into 10 and 10 goes into 10. So I'm going to change that 2 fifths to have a denominator of 10, which means I need to multiply the 5 by 2, and thus multiply the numerator by 2. So we end up with 4 over 10 as our equivalent fraction. So rewriting our problem, we have 4 over 10 for the first fraction, and we're subtracting 3 over 10. And then remember that now that we have the same denominator, we can keep that denominator, and we do 4 minus 3, which is 1, and then we get 10 again for our denominator. So that's the final answer here. Okay, so here's one more of these. These have different denominators. We start by getting an improper fraction, and then I'll remind you that at the end of every problem, if you can simplify or reduce the fraction, you should. So I'm going to give you a minute to try this one out. Go ahead and pause your video here. Here are our notes for this problem. When you change 2 1/3 to an improper fraction, you get 7/3, and then you need a common denominator. And our least common denominator for this situation was 9. And we end up with 21/9 for that second fraction. So adding the fractions together, we have 26/9, which as a mixed number is 2 and 8/9. Okay, so lastly, we're going to have multiplying and then dividing fractions. So when we multiply fractions, we simply multiply straight across. So we would get 4 times 1 is 4, and 7 times 5 is 35. And like I was saying before, if you can simplify at the end, you should. But on this one, we can't, so this is our final answer. Okay, so here's one for you to try. If you think you can reduce at the end, I'd like you to do that. So please pause the recording and try this one out. All right, now we haven't really gone over simplifying very much yet. And so when you multiply straight across, you do get 15/90. But then you look to see if you can divide 15 and 90 by anything. And we can. The first thing I notice is they're both divisible by 5. So if I divide 15 by 5, I get 3. And it turns out that 90 divided by 5 is 18. And then you check one more time, see if you can divide by anything. And we can. We can divide both of those by 3. So I'm going to divide 3 by 3 and we get 1, and divide 18 by 3 and we get 6. So that would be the final simplified answer. Now that's one way to do the problem. You can also choose to simplify first. And the way that you do that is you look in numerators and denominators and see if there's anything you can simplify. For example, 3 and 9 share a common factor, which is 3. So 3 divided by 3 is 1, and 9 divided by 3 is 3. And looking at the other two, the other pair, I have a 5 and a 10, and I can divide both of those by 5. So 5 divided by 5 is 1, 10 divided by 5 is 2, and all of a sudden I am now doing the problem 1/2 times 1/3. And multiplying straight across, we get 1/6. So either way, we get the same final answer, but some people like to simplify at the end, some people like to simplify at the beginning. Personally, I like to simplify at the beginning because my numbers don't end up being so big. So if it's difficult for you to reduce something that has, say, a denominator of 90 or 180, then maybe you want to try simplifying at the beginning. Okay, so here is one more problem with multiplying fractions. I think it's one more. Let me double check. Yep, so I want you to try changing this first to improper fractions, which really is the only option here. You need to change them both to improper fractions. And, well, I guess it's not the only option, but it's perhaps the easiest option right now. So, and then multiply straight across. So I'll give you a minute to pause the recording and try it out. All right, so we end up with 2 1/2 turning into 5 halves. 3 4/5 turns into 19/5. And then I chose to simplify my 5 and my 5, so I divided those out and got 1s. And then we have 19/2, which as a mixed number would be 9 1/2. Okay, so that's it for multiplying, and now we're going to learn lastly how to divide fractions. And to divide fractions, you multiply the first fraction by the reciprocal of the second fraction. Some people know this rule as keep, change, flip. So what you do is you keep the first fraction the same, and then we multiply by the reciprocal of the second fraction, or we flip the second fraction. So we keep the first fraction, change to a multiply sign, and then flip the second fraction. So we end up with 3 times 2 is 6, 4 times 1 is 4, and then we note that both of those are even, so we can divide them both by 2, and we would get 3/2. So that's our final answer. So keep, change, flip. That can be a way to remember to multiply by the reciprocal. So here's problem number 2. Again, I'd like you to pause the recording and try this one out. Okay, I'm hoping you can read my work on this one. We would keep the 6 over 11, change to a multiply sign, and then multiply by 5 over 12, which is the reciprocal of 12 over 5. And then I simplified my 6 and my 12, which is, in my opinion, quite a bit easier than multiplying straight across and getting those large numbers. So 12 divided by 6 is 2. So that's how you can see my work written there. So then we have 1 times 5 and 11 times 2, which is a fairly simple multiplication problem. Okay, so here's our last one, and I'm going to go ahead and just show this one, explain how to do it. So again, we want to change this mixed number to an improper fraction. So 1 times 5 is 5, plus 4 is 9. So we have 9 over 5 divided by 3. And instead of writing 3, I'm going to choose to write 3 over 1 because when we have whole numbers and we're working with fractions, it's helpful to write the whole number as a fraction. So just put it over 1. And then it's a little clearer what to do on the next step because we need to keep our first fraction the same with 9 over 5, then multiply by the reciprocal of the second fraction, which is 1 over 3. And then we multiply straight across and we get 9 times 1 is 9, 5 times 3 is 15. And then you notice that we can divide those both by 3. So 9 divided by 3 is 3, and 15 divided by 3 is 5. And if simplifying is challenging for you because you don't see it right away, keep practicing because the more you look at numbers and the more you think about factors, the easier it's going to get and you're going to be really good at it after a while. Now that's it. We've covered all of our objectives for today. So thank you for watching. I hope it was a good review and helped to clarify some things maybe you weren't sure about. Here are our 5 questions to answer as a quiz for this asynchronous session. So please make sure to open up a message to me and type your answer to these 5 questions and then send me your answers once you've finished. And thank you again for watching and have a great week.